Good morning. Today we will be doing lesson 16. In this lesson, we will review the rounding of whole numbers. We will review how to estimate the solution to a problem, and we will review bar graphs. Looking at page 72, we read that when we round a number, we are finding another number, usually ending in 0, that is close to the number we are rounding. Oftentimes, a number line can help us visualize this process. For example, if we're given the number 667 and asked to round to the nearest 10, then we need to ask ourselves, is 667 on a number line closer to 670 or 660? Notice in this case we were asked to round to the nearest 10, so we need to ask ourselves which two multiples of 10 are on either side of 667. In this case, we have to choose between 670 and 660. In order to round, we look at, since we're rounding to the nearest 10, we start with the digit in the tens spot and look to the next digit to the right. In this case it's a 7, and therefore we round up to 670. Remember, if the next digit is 5 or above, we round up. If it is less than 5, we round down. In example 1, we're asked to round 6,789 to the nearest 1,000. Well, the two multiples of 1 that this number falls between are 6,000 and 7,000. To determine which way to round, we start at the thousands place value spot and we look to the next digit to the right. In this case, it's a 7, therefore we round up, and we would round this entire number to 7,000. In example 2, we're asked to round 550 to the nearest 100. Well, on a number line, the two multiples of 100 that are on either side of 550 are 500 and 600. We start with our 100 spot. We look at the next digit to the right. It's a 5. Therefore, we remember that we round up, and this number would round to 600. In the case of estimating, I need you to remember the following two steps. Whenever you see the word estimating, what we are going to be doing is first round our numbers, then solve. Once again, and say it with me. When we estimate the solution to a problem, we first round, then solve. Estimating is very helpful when we're just trying to quickly come up with a general answer, where we just want a quick answer and where close is good enough. And oftentimes out and about in the everyday world, an estimated answer is good enough. In example 3, we're asked to estimate the sum of 467 and 312. Well, first of all, we remember that sum means we'll be doing an addition problem. In order to estimate this sum, we first round, then solve. So, 467, another real quick note, if you're not told what number to round to, whether it's the tens or the hundreds, go for the largest place value spot that you see in evidence. Therefore, since we're not told or given the indication we should be rounding to the nearest tens, we are going to round to the nearest 100, because we do have digits going out into the hundreds spot. So, rounding 467, we would decide that it rounds to 500. Rounding 312, we decide that we will round down to 300. The sum is the answer to an addition problem. 500 plus 300 is 800. Therefore, the estimated sum of these two numbers is in fact 800. In the lesson practice today, you will be asked to perform assorted estimating problems. Even though I'm sure you're capable of rounding and then solving in your head, please go ahead and write out and show me your estimated numbers as well as the math operation you've chosen to do, and then circle your answer. We will move on and quickly look at bar graphs. Our book tells us that bar graphs display numerical information with shaded rectangles or bars of various lengths. Bar graphs simply take information or data and put it into picture form, which can help our brain understand and make assumptions or gather information in a very quick and efficient manner. Bar graphs are often used to show comparisons. So, in example 4, we see the following bar graph. First of all, a good graph will always have a title. In this case, we are looking at the population of Ashton between 1960 and 1990. In addition, a graph will always have a y-axis that is vertical and a horizontal axis, which is called the x-axis. Excuse me, I might not have said that correctly. I'll review it again. The vertical axis is known as the y-axis. The horizontal axis is known as the x-axis. And that word that I am saying is spelled this way. And so a good bar graph will also have a title for the y-axis, or something that indicates what the labels or units of measurement are. And likewise, the x-axis will have some sort of labels. And so, looking at the x-axis, we see that we will have information for the year 1960, 1970, 1980, and 1990. Looking at the y-axis, our little mini title here says that we're looking at the population in thousands. Therefore, we have a 0 right down here. The first line has a 2, which means this would be 2,000. The 4 would represent 4,000. The 6 represents 6,000, 8,000, and 10,000. The question we are asked is about how many more people lived in Ashton in 1990 than 1970. Well, here's our 1990 information. Here's our 1970. Now it looks like in 1970, if we follow the height of the bar, it stops right at 4,000. 1990 is a little bit trickier. It is somewhere in between 6,000 and 8,000. To my eyes, it looks like it's halfway in between the two. Therefore, I will suggest that that is 7,000. This was 4,000. How many more people lived in Ashton in 1990 than 1970? The difference between 7,000 and 4,000 is 3,000, and therefore I would answer the question 3,000 more people. It's your turn to practice. I'm going to ask that you look at your lesson practice answer sheet and only do the following problems. B, D, F, H, J, K, L, and M. Please remember to show me your rounded numbers, show me your math operation, write your equal sign, write your answer, and give it a circle. You're probably saying, Mrs. Martin, we don't have an N and an O space on our lesson practice page, and you're right. So go back and use one of the blanks that you're up, perhaps your A spot or your C. I would like you to go back and, using the graph from example 4, answer both N and O.